My name's Aloho and I'm a graduate of MIT. This video is on part 1 of acidity and basicity. Chemists have long struggled to come up with a way to describe acid and base reactions that is at the same time physically relevant, specific enough to be accurate, but general enough to include everything that should be considered an acid and base relationship. So let's start off by setting up definitions of the 3 types of acids and bases. Arrhenius defined an acid as a species that dissociates in water to produce a hydrogen ion, or H+. And he defined a base as a species that dissociates in water to produce a hydroxide ion, or OH-. Although useful for certain reactions, this definition isn't quite adequate to describe acidic and basic behavior in non-aqueous medium. Brønsted-Lowry provides a more general definition for acids and bases, one which will be most useful for biology. A Brønsted-Lowry acid is a species that donates hydrogen ions, thus increasing the concentration of hydrogen ions in a solution. A Brønsted-Lowry base, on the other hand, accepts hydrogen ions, thus decreasing the hydrogen ion concentration in solution. Brønsted-Lowry acids and bases usually occur in pairs because the definition requires the transfer of a hydrogen ion or a proton from the acid to the base. They are known as conjugate acid-base pairs. In this example, the hydronium ion H3O+ is a conjugate acid of the base H2O. And then NO2- is the conjugate base of HNO2. Lewis defined acids and bases based on their ability to accept or donate an electron pair rather than a hydrogen ion. Lewis acids accept an electron pair and bases donate an electron pair. The relationship between all 3 definitions are as follows. Every Arrhenius acid is also a Brønsted-Lowry acid, and every Brønsted-Lowry acid is also a Lewis acid, and likewise for the bases. However, the converse is not true. Every Lewis acid is not a Brønsted-Lowry or an Arrhenius acid. Now let's talk about the acidic and basic properties of water, H2O. Water is known as an amphoteric species because it can either be an acid or a base depending on the solution it's in. It's also able to undergo auto-ionization, meaning it can react with itself. If we had 2 molecules of water react in a reversible reaction, it can produce a hydronium ion, or H3+, and a hydroxide ion, or OH-. This is a reversible reaction as indicated by the double arrow right here. The forward reaction is the dissociation of water into hydronium and hydroxide ion, while the reverse is the formation of water, 2 molecules of it to be exact. In pure water, the concentration of hydronium ion, which is sometimes denoted as the hydrogen atom, H+, and that of the hydroxide ion are equal. But adding certain solutes, or acids or bases, disrupts this balance. Biologists use the pH scale, which is based on the log of the concentration of the hydrogen ions, to describe how acidic or basic a solution is. The measure of pH, or the concentration of hydrogen ions, is very important for complex molecules in living organisms, as you'll learn more about later.